Okay, so we're going to be taking a look at an ion that has 35 protons and 36 electrons. So I'll do number 1 up here just to kind of refresh your memories. And then you guys can try 2 on your own. But if you guys feel confident doing this, you can just ignore me and just answer it out and just check your answers. But in order to start, we're going to look at how many protons it has in order to find the element. So 35, so we go to the periodic table. We're going to zoom in a little. And then if we take a look at 35, we have Br, which is bromine. So the 35 protons tells us that we got bromine. Okay. All right, we want to figure out the charge. So if you guys remember from last time, the charge is just protons minus electrons. So we just take the protons, which is 35. We subtract the electrons, 36. That's going to give us -1. So your answer is going to be Br and then a minus sign on the top right. That's it. That's pretty much what we learned last time. I know I went through that kind of quickly. Any questions on that though? As long as you have this formula right here, the protons minus electrons, you should be able to get the charge. And then the last part, is it a cation or anion? It's negative, so it's going to be an ion. Okay, remember, an is bad. It's the name of the girl that broke my heart in kindergarten. Okay. All right, so I'll give you guys about 2 minutes to see if you guys can do number 2 on your own, and then we'll go over together, and then we'll go on to the new stuff for today. All right, so same thing with this one. We're going to look at the protons. So 26 protons is going to give us, where is it? It's going to give us iron, Fe. Okay, so we're going to write Fe for the protons. And then we got to find the charge using the electrons. So same thing as before, protons minus electrons. So 26 minus 23. And that's going to give us +3. Okay, so the charge for this guy is going to be 3+. And since it's positive, it means that it's a cation. Okay. So that's the review from last time. Finding charges, just subtract the protons and electrons. Okay. All right, any questions on that? All right. All right, so today we're going to be continuing to talk about ions, actually until the test. So pretty much the rest of the unit, it's all going to be ion stuff going forward. We're going to review isotopes every now and then, but for the most part, we're going to be looking at ions going forward. Okay, so let me go down. Just make sure you guys titled the lecture is called Most Common Ions. And so we'll be talking about the most common ion that each element wants to become. Okay. All right. So with that being said, let's get into it. So like I said, most common ion, we can abbreviate it as MCI. So the vast majority of the time, I'm going to write MCI. If you see MCI on your assignments, on your quizzes, anywhere going forward, just know that it means most common ion. Okay. And that's the ion that the element wants to become. Okay, so just make sure you guys jot that down so you have it as a reference, because I will be using mostly the term MCI because most common ion is really long to write and to say. MCI is just a lot easier. Again, most common ion, it's the ion that an element wants to become. Okay, and so I got a periodic table right here. We're going to be looking at we're going to be writing on your periodic tables now because there's a pattern that we can follow in order to figure out which ion each element wants to be. So again, if you don't have your periodic table, make sure you guys take it out. If you guys like a perfect copy, you can grab another one because you will have to write on your periodic table. But yeah, okay, we're going to learn about MCIs and how to identify them. All right, so let's take a look at your periodic tables. Again, we're going to be writing on it, sorry. And let's go over the pattern. So there's a pattern for the ion that everything wants to become. So let's start from the left, okay? You guys see this first column, group 1 with hydrogen, okay? All the elements in this column right here, they all want to become +1, okay? So what that means is hydrogen wants to become H+, lithium wants to become Li+, sodium wants to become Na+. You guys don't need to write this down, but that's just what I mean. I just mean that everything here wants to become +1, okay? Which means they all want to lose one electron. Okay. And we're not going to talk about why until the end of the year. You'll just kind of have to trust me on this. But later on in the year, we'll talk about why exactly they want to lose one electron. Okay. Okay, so that's the first column. Okay, when we move on to the second column, it's a very easy pattern. Everybody in this column wants to become positive 2, which means they want to lose 2 electrons. Okay, so that means, again, you guys don't need to write this part down, but Be wants to become 2 plus. Magnesium wants to become 2 plus. Calcium wants to become 2 plus, so on and so forth. Everybody in that column wants to become positive 2. Alrighty, let's go on to the next section. So you guys see this middle section where the periodic table drops, right? It's kind of like tall, tall, and then it drops really suddenly. So this area right here, groups 3 through 12, there's actually no pattern. Okay, these are called the transition metals. Okay, and these guys, they do not have an MCI. Okay. And what I mean by that is that some of them, they like to become multiple ions. Okay, so for example, and you guys don't need to write this down, iron can become positive 3, positive 2, positive 1. So it likes to be multiple ions. So there's no real pattern for this middle section. And so you guys don't need to memorize anything for this section. All you need to remember is that the elements here in the middle, there's no pattern for those. Okay, I'll just be giving you guys what their charges are. All right. All right, let's go to the next group. So this column right here, group 13. It's actually going to pick up where we left off on the pattern. Everybody here wants to become positive 3. Okay. All right, let's move on to group 14. The next one, this is where it kind of changes. Oops, I'm going to do blue. Okay. This column right here, they want to become negative 4. So we go 1, 2, 3, positive, and then it goes to 4, but it switches to negative. And then the pattern kind of continues from there. This column right here, 15, they want to become negative 3. And then we actually finish up from there. This one becomes negative 2. And then these guys want to become negative 1. Yes.
What about groups 18 through
The ones at the very bottom, right?
the ones like all the way?
All the way at the bottom. Yeah, they're actually part of the transition metals, so there's not going to be no specific MCI.
No, I mean the one group with like
Oh, this one, 18, sorry. I'm about to get to that, but 18, they want to be neutral. These guys do not like becoming ions. They don't like giving or gaining or losing electrons. They're happy exactly the way they are. All right, and so that's the pattern. I will expect you guys to know this for the test. Again, you don't need to memorize this part. Just 1, 2, 3, negative 4, 3, 2, 1, neutral. Yeah. Yeah, those guys are part of the transition metal, so they also have no MCI. Good question. Yeah, so these guys right here at the very bottom, they have no MCI as well. If you guys see these lines, this is kind of telling you that these metals in the middle or the bottom, they kind of go in that section, and that's part of the no MCI section. Okay, good question. All right, so you're only really responsible for the columns that I gave you the pattern for. All right. All righty. Any questions? Hopefully that's not too bad. Again, you will have to know this for the exam in October. But you'll have plenty of time to memorize that, and you guys will probably get it as you do the assignment. All right. All right. Anybody still need to copy this down? Okay. Yeah, I'll leave this up here for another minute. All right, so again, I will tell you guys what you guys need to write down and what you don't. You guys do not need to write this part down, but the key principle for the rest of the unit is that these cations and anions, these positive and negative ions, they are attracted to one another. So if there is a positive ion, and again, you guys don't need to copy this down. Okay, if there's a positive ion and there's a negative ion, okay, they're attracted to each other. So the positive one will see the anion and be like, oh, she's pretty cute. So they'll get closer. The anion's like, oh, she's pretty cute. And then they'll get closer and closer together, and then they will combine and they'll get married and they'll become one molecule, right? And that's why we call it chemistry, because it tells us things about the real world. Okay. But the key thing is that positive and negative ions, they are attracted and they combine together. Okay. And you guys don't need to write this full thing unless you really want to. The key thing, just remember, opposites attract and then they combine together. All right, now this next part, I do want you guys to write down. Okay, when the positive and negative ion, they combine, they make a molecule called an ionic compound. Okay, which makes sense. They're ions and they combine to make a compound. So ionic compound. All right, and then the key thing that I do want you guys to note and write down is when you guys write the formula for the ionic compound, always write the cation first, okay? You will lose points if you guys don't do it in order. Always put the positive ion first and then the negative ion second. And I'll tell you guys how that works in just a second. We'll do an example problem together. But when you guys write down the formulas for an ionic compound, always write the positive one first. Okay, we want to start off on a happy note. And that's pretty much all the new info you'll need for today. We're just gonna go through 3 quick practice problems, and then you guys can get started on your assignment. Okay. Okay, let's do number 1 together, and then I'll have you guys try a practice problem on your own. So we're gonna get started by looking at most common ions again, so MCI. So on your paper, I just want you guys to write down what is the MCI that Na and oxygen are going to form. So using the periodic table and the notes we just took, write down what MCIs are going to form. All right, so let's take a look at our periodic tables and see what MCIs they're going to or they want to become. So if we take a look at sodium, sodium is in this column right here, the first column. So what's the MCI that sodium wants to form? Yeah.
+1?
Yeah, +1. So you should have written down Na plus. And the other one is oxygen. And what's the MCI that oxygen wants to form? Yeah.
2 minus.
Yeah, 2-. So O2-. You guys can just yell out the answer. You don't need to raise your hand for this. Okay, so you should get Na plus and O2-. Everybody good with that? Okay. Again, just look at what column they're in. So Na plus and O2-. All right, now these guys are going to be attracted to each other because they're positive and negative, and we just need to figure out what compound they're going to form. However, we need to make sure the positive and negative energy, they balance out. So the way I like to think about this is like a friend group, okay? So in a friend group, you need a balance of happy energy and sad energy, right? If there's too many happy people, it just becomes really annoying for everyone around you, right? But if everybody is sad, then it's like, I don't know, it's just depressing to be around you and nobody wants to hang out with you. So same thing here. If you guys take a look at the positive and negative energy, do we have more positive or negative energy right now? Yeah, negative, because it's -2 versus +1, right? So there's way too much sad energy. So oxygen is way too sad. It's too negative. So we need to balance it out by giving oxygen some more positive ions, some happy friends. So we got 1, but 1 sodium is not enough to balance it out. How many sodiums will we need in total to balance it out? Yeah, 2. So if we add 1 more sodium, we got +1, +2, and then we can balance out oxygen's sad energy. Okay, and so that's how we can figure out how many of each ion we need. Okay, not only do we need a positive and negative, we need the correct amount of each of them to balance out their energies. All right, so they're going to combine together and they're going to form, we're going to write the cation first, Na, and we're going to write O. But if you notice, we have 2 NAs, right? So we just put a 2 behind the Na. And that's it. That's how you write the ionic compound. Okay, so a couple things to juggle. First one is make sure the positive and negative, they balance each other out. Second, make sure you write the positive one first and then the negative one second. And then third, just put the correct number of each behind them. So for example, if we needed like 3 oxygens, you would put a 3 behind the oxygen. But that's not the case here. You just need 2 sodiums. Okay. Alrighty. You guys think you could try one on your own? Okay. I know it's too early for this, right, guys? I really don't know how you guys study chemistry this early. Okay, so I'll give you guys about 2 minutes. See if you guys can try number 2. We'll go over it, and then I'll give you, I guess, the hardest problem you'll see today, or hardest type of problem you'll see today. And then guess you start on your assignment. So try number 2. You can check with the person next to you, and then we'll move on to the last problem. Okay, so we got aluminum and chlorine. So you guys can just yell out their MCIs. What's aluminum's MCI? Yeah, 3+, +3. Okay, let's go to chlorine. What's chlorine's MCI? Yeah, -1. So here we have +3 and -1. And if you guys notice, we have way too much positive energy this time, right? It's like where you have that one person in your friend group that's always happy, even in the mornings, even late at night, and it gets a little bit annoying for everybody, right? So we got to bring this person down a little bit, okay? So we're going to add chlorines until we get 3. Now we got 3 sad ions to balance out this super happy person, okay? It's because it's +3 and then -1 for the chlorines. Okay. And so if you put those together, you get AlCl. So remember, write the positive first, the negative second. And since we have 3 chlorines, we just put a 3 behind the Cl. And there you go. We have our ionic compound. All right. Hopefully that's not too bad. Your numbers won't get really big today. You'll be working with single digits pretty much the rest for your assignment today. Okay. But any questions on number 1 and 2? Okay. Let's do number 3 together. And I wanted to do 3 because this is probably the hardest problem that you'll get today. So if you guys can figure this out with the person next to you on your own, then great. You're ready to go for the rest of the day. But if not, that's why I want to go over it. So I'll give you guys about 2 minutes. See if you guys can try number 3 on your own. And then I'll go over it with you guys before getting you started, okay? Okay, so for this one, we actually don't need to find the MCI for one of them. If you guys take a look, the positive one, the cation is Ti2+. So we'll write Ti2+. And then we're going to look for phosphorus's MCI. Okay, so if you go on the periodic table, phosphorus is P. And then the MCI for phosphorus is going to be 3-. Okay, so hopefully you'll be able to find that. All right, next what we have to do is we need to make sure the charge is balanced. So if we take a look at it, do we have more positive energy or negative energy? Yeah, negative, right? -3 or 3 is bigger than 2. So that means we need to add some more positive energy. So we're going to add another Ti. But if we do that, now the problem is we have too much positive energy, right? So we got to try to balance it out again. So we're going to add 1 more phosphorus, and then we run into the same problem. Now it's too negative. So we're going to add another Ti, and then that's going to lead us to have a total charge of +6, and then a total charge of -6. Now they're finally balanced, and so we can write the ionic compound. So we're gonna write TiP. There's 3 TIs, and then there's 2 phosphoruses. Okay, so that's how you would do that. So when in doubt, if the charges aren't balancing, just keep adding positives and negatives until they balance. I will guarantee you guys the number will never ever get bigger than 5. So if your number gets bigger than 5, you messed up somewhere. So just make sure you go back and double check your work. Okay. Alrighty, so I'll give you guys the rest of the class period to work on that assignment, the most common ions. There is a quiz as well, so just make sure you guys check that out. And if you have any questions, please let me know.